everyone. Thanks for attending. I know it's mid-afternoon on day 2, and so it's great for you all to come out here. We're going to talk a little bit today about Room, and that from the Android architecture components. My name's Mark Murphy. You may know me from the Busy Coder's Guide to Android Development, or 19,000 and some odd answers on Stack Overflow, or various and sundry other things. But enough about me. Let's talk a little bit more about you. Quick show of hands. How many of you have already played around with Room somewhat? Reasonable number. How many of you have not yet played around with Room, but you've at least watched a conference presentation on Room, such as from Google I/O, etc.? Okay. For those of you who didn't raise your hands, again, I know it's partway through the day, and that raising the hand is so hard. And of course, those of you watching on the video, and I assume some of you raised your hands, and I just really can't see you there through the lens and stuff. But today we're going to talk a little bit about bits and bytes, and we'll look at some code, and that for those of you who have never seen Room before, so we'll get a little bit of the syntax and so forth. But we'll also more talk about kind of philosophically, where does Room fit, and why is Room kind of set up the way it is, and so forth. Next question for you. How many of you attended a presentation yesterday by Alex Strong and Jake Wharton on resurgence of SQL? Good. And for those of you who didn't raise your hands, I won't tell Jake that you didn't attend, but if your Kotlin code all of a sudden stops working, I'm not saying, but so in that presentation, they focused on okay, hey, SQL is, in their words, back. From my standpoint, SQL didn't really go anywhere. They made it sound like that people were desperately avoiding SQL. From my standpoint, we were just slogging through this stuff, and that trying to make sense of why when we query a cursor it doesn't actually do the query and so forth, and dealing with all the content values stuff, and that the making sense of loaders and all those fun things. So SQL is definitely resurgent, but it's not like it had gone anywhere. And so Room is here to try to help simplify a lot of this stuff. I teach Intro to Android courses. So far, since 2009, when I teach SQLite, I've had no little choice but to teach the direct API. Next year, if I'm teaching this course, most likely I will switch to just teaching Room, and because it is a fair bit simpler. And part of the reason why it's simpler is just kind of figure out how to think about it. Trying to draw comparisons and that to other things. So, next question for you. How many of you are familiar with the ultimate in VC pitch lines? It's like Uber, but for blank. And in what's going to sound like a total non sequitur, how many of you have worked with retrofit? I'm surprised that more of you know retrofit than know the it's like Uber line. But okay, Room, it's like retrofit, but for SQLite. There is a lot of similarities. I'm going to beat this analogy into the ground, over the course of the presentation. And for those of you who did attend the Resurgence of SQL presentation yesterday, I actually did write these slides before Alec pointed out the analogy between Room and retrofit in the presentation. First things first, let's take a look at some code. And I'm one of those weirdos who I don't program in like Keynote or something. I program in Android Studio. So looking at Android Studio here so we've got some code. And now, retrofit, when we start off, first thing we need to do is we need to set up POJOs that model the response from the server. I'm going to be hitting the Stack Overflow API for reasons, so I want to get back a list of questions in a certain tag, and so the way that Stack Exchange API is set up is that we get back, when we make a particular request for the questions, we're going to get back an object that contains an items array that contains all of our questions in terms of the details, tags, titles, and so forth. I don't really care about a lot of that data. I just want the items, where each item, all I'm worried about is getting back the title, so the display name, and the link, the URL to the question itself. You don't necessarily need a whole lot of things that are specific to retrofit here. Maybe you've got some serialized names attributes or the equivalent, and for your parsing of the responses, and to clean up the JSON to something more Java friendly. But otherwise, this is fairly pure. So in retrofit, you create POJOs that model your objects. In Room, you create POJOs that model your objects. Where with retrofit, you may have annotations. With Room, you certainly are going to have annotations. Your model objects are going to have entity annotations, where you're going to provide the details. The annotations are going to be much more verbose in Room because we've got more work to do. I mean, we're not just talking to a server, we are storing the data locally ourselves. And so we're going to have to provide information like our table name. What is it that we're looking to store this stuff into? What's our primary key? Is it going to be an auto-increment integer? Is it going to be some UUID and that we're going to generate in the app itself? Whatever. So, next step is that you're going to create, in retrofit, you're going to create an interface that describes this is how we want to retrieve the data from our data store, in this case from the server. So you're going to say, all right, I want to retrieve from a questions URL, I want to add in some query parameters along with my URI, and I want to get that SO questions back, saying I want to get back my model object, and that here is the way I want to interact with it. In my case, I'm only asking for one thing, but you could have several different methods on here, requesting several different URIs, and that getting several different types of responses back. With Room, you're going to create an interface, and that is going to stipulate this is how I want to get my data back, how I want to work with my data store. You'll annotate that as well. You will have annotations on individual methods where you provide your SQL. And that for your queries, whether it is something simple or we'll see examples of some stuff that's a little bit more complicated later on. You'll also have it for all your data manipulation, and that the insert, update, delete methods, and that the correspondingly annotated saying, hey, I've got my model objects, I want to now put them into my data store by one means or another. I want to remove them from the data store, and so on. So, POJOs, interfaces. Next step with working with retrofit is to go in and say, all right, I need to get myself an object that models the overall data store itself. And so I'm going to say, oh, okay, here is the base URL that those URIs in the interface apply to say this is completing the request, and that for what server I'm trying to hit. I say, oh, okay, I'm expecting to get JSON back from that server. We'll use JSON in order to convert that into my POJOs. Now with Room, you do the same basic thing. You're going to have a Room database that's going to be able to go in there and where you say, oh, okay, I'm going to store this stuff in a tripsdb file that when you create your Room database, you're going to go in and say, oh, okay, I want to build me a Room database. It's going to be using this Java class for the definition of it, and here's where I'm filing the stuff. You're going to say, oh, okay, the sorts of things that I want to store in this Room database are these entities. In this case, there's only the one. There can be lots. And that this is my version number. Same thing as we do with SQLite Open Helper in the native SQL API in Android. And retrofit will be able to turn around and give you an instance of your interface class synthesized on the fly. It's going to code generate the implementation so that you can turn around and actually call the methods on that interface, even though you never created your own implementation of it yourself. So I can ask for the Android questions, get a call object, and arrange to do the work. Room, you're going to turn around. You are going to be able to call a trip store method. We define that as an abstract method on an abstract class, but the database object that we get back from the Room database builder is a generated concrete implementation of it. It's going to know how to turn around and give us a trip store. I hate trackpads. And that get us our trip store back so that we can turn around and retrieve our objects, map to our POJOs that we saw fit. And so Room is inspired by retrofit. How much they actually leveraged that directly, I can't say. But you create the POJO, you have annotations to say, all right, here's my entities, what I want to store in the database, here is how I want to retrieve them with all your lovely SQL for what you want to try to get back. Here's how I want to manipulate them. Here's the ways I want to insert, update, and delete them. You have an annotated interface for all of that. You create an object that represents the overall data source, and that object is going to give you back the interface implementation to do the real work. If you can feel comfortable with retrofit, Room is a very easy jump. The details are in all of the annotations. What are all the knobs we can turn and switches we can throw on our entities, on our Room databases for things like foreign keys and indices and all the goodness that's inside a SQL that you may want to take advantage of inside your Android app. Beyond that, both retrofit and Room support some form of reactive response, though I couldn't quite figure out the nounified version of reactive, so it's something or another. And so with a retrofit, you can turn around and say, okay, well, I want to get an observable back, and rather than a call object. And so you can turn around and arrange to subscribe on the observable and be able to get the responses when they come in that way, whether you were doing that directly, merging it in with other events, whatever makes sense for your particular chains. Room also allows you to say on your queries that rather than just getting a synchronous call with a list of trips or trip objects, I can do a flowable, and I can do a single, I can do a maybe, and be able to have them be reactive that way. But you can also go in and say, I want to use live data from the architecture components, and that you can't do that with retrofit today out of the box. And that the retrofit does not have built-in support for live data. Last I checked, maybe they added it in the past couple of weeks. And so you can say, all right, so in all of these cases, this stuff is reactive. I'm going to be able to get the stuff asynchronously. And in the case of Room, it's kind of a little like content providers and content observers in that if there are data manipulation changes in certain circumstances, you can get the updates delivered to you as well. And so not only do you have the one-shot initial load, but data changes may trigger additional calls to your flowable so that you know whether or not, or your live data, to know whether or not that data has been manipulated. And so they both support reactive Java 2, and that the live data supports, Room supports live data right out of the box, and that you don't have to do anything extra. Retrofit says, that'd be great if somebody would, kind of go and do that for us. Because both Room and Retrofit also support their extension points. Retrofit can be extended in lots of different ways. And that you can set up a call adapter to say, okay, how do I want to bridge into these different sorts of approaches? How do I adapt a call object to chain into some other framework, whether it's the original RxJava, RxJava 2. In principle, somebody can create an extension for live data in order to be able to allow Retrofit to directly support a live data response type. You can say, okay, well, my payload is going to be JSON, and so I'm going to get JSON or Moshi or Jackson embedded into here and use that as my JSON parser because I'm using that maybe elsewhere in my code, and then I'm going to stick with the same JSON parser across the board rather than having more than one. Or maybe I'm using something else. It's protobuf based, and so I've got wire in there. It's XML based, so I'm using simple XML, whatever. And Retrofit layers on top of OKHTTP. You've got all of OKHTTP's extension points, particularly interceptors, for being able to go in and say, okay, I want to be able to see all of the calls that come through for logging purposes, or I want to be able to manipulate some of them to be able to inject authorization headers, whatever is necessary for being able to interact with my web service. Room doesn't have as rich of a support infrastructure for that, but it's getting better. And that in particular, Room, as Jake and Alec pointed out yesterday, doesn't directly work with SQLite. We tend to think of it that way because it's the net effect of the core and stock implementation. But in practice, Room is really talking to a support database API, a wrapper around an abstraction of a database that just happens to look a whole lot like SQLite. Where the default implementation, if you don't say anything otherwise, that will be real framework SQLite. But that is a pluggable implementation. You can say, as part of setting up the room database, I'm going to replace that with something else. And that in principle, it could be anything else. The API looks a lot like SQLite database, SQLite Open Helper, and so forth from the framework. And so it'll work best if it's SQLite, but it doesn't have to be the framework SQLite. For example, SQLCipher for Android is the leading solution for an encrypted database. You can create a wrapper around SQLCipher for Android that implements the support database API and turns around and plugs into Room. I implemented one in the form of the Safe Room library. So you can go in and, as part of your database builder for setting up your Room database, in addition to saying, okay, well, here's my Room database subclass, here's the file where my stuff is, you call Open Helper Factory to say, all right, I want to override the default. Rather than the framework implementation, I'm going to supply my own. I have one that's a Safe Helper Factory that goes in turn, reaches out and creates wrapper objects for all of the other classic SQLite things like SQLite database, where I'm using the SQLCipher for Android implementation under the covers. And the only real difference between the two is that you've got to provide me with a passphrase, such as here, some sort of an edit text where the user has typed in the passphrase. You pass in the editable for that, and now I will use that for if we're creating the database anew, and that we'll use that to encrypt the database. If the database already exists and we're opening it, we'll use that to decrypt the database. And because it's an editable, and that I'll even null out your passphrase for you so that it doesn't hang around in memory any longer than it needs to. Everything else is the same, and that you use Room no differently than you would with a regular SQLite database. There's also implementations of a non-SQLCipher independent packaging of SQLite, specifically so you have the same version. One of the dirty little secrets in Android is that SQLite keeps being updated with each new version of Android. And as a result, some features you may be looking for, like full-text searching, FTS3 has been around for pretty much all of Android's life, but FTS4 was introduced to us in like API level 14 or 15. FTS5 is been API level 24 or thereabouts. And so as a result, maybe the feature set that you want isn't going to exist across your normal Min SDK version. Maybe you don't need the encryption, but you do want to have an independent SQLite so that you have the same implementation across the board for everywhere you're deploying. Well, people have already packaged that up with the same support database API to be able to plug that in and use Room without having to change any of the Room stuff and just direct to your own separate SQLite libraries as opposed to the framework implementation. Room and retrofit are also reminiscent in terms of how we deal with relational data. Retrofit in any sort of a web service environment, and that the payloads that we get back from the web service do a fine job of modeling straight up object ownership. One-to-one, one-to-n sorts of relationships where there is a strict sort of a parent-child ownership and there's no independent entities. But where we do have, whether it's M-to-N relations, or in certain cases where we just have extra data that isn't being supplied to us in the original call, we may need to make multiple retrofit calls in order to get all the data that we're really looking to manipulate and stitch that stuff together. Okay, come on, behave. So, for example, in that Stack Overflow API, part of the information that we get back for an individual question is the owner, who asked the question. We get back a reasonable number of pieces of data about that owner straight in the questions API. And then when we make the web service call to get our questions, we get back things like their user ID and their profile link and their profile image and that for your avatars and so forth. But really, there's a lot more to a user. There's a separate users endpoint, URI that you can invoke, where you can get things more about like, how's their reputation been changing, and that what's their accept rate, and that are they a Stack Exchange employee, and so forth. Maybe in your app, you don't need all that stuff. You just need these basics because the Stack Exchange API effectively denormalized the data. You get little bits of this, but this is an end-to-end relationship. And that the questions, and that rather really a one-to-end, and that a question will have an owner, but owners may have many questions, lots of questions. And so maybe in your app you need more of this information, but if you're going at it from the question side, because you're looking for things like tag for Android, you don't get all the data you need. You may need to turn around and make other requests of the web service in order to be able to get all the information you want. Now, the classic ORMs, and that try to hide those details. The POJOs that you get back, and that from a lot of these ORMs, will have getters for modeling the relationships. And that, for example, if I take a look here at GreenDAO, and now one of the more popular ORMs, we've got an order, and that we have a customer, and we say that, okay, an order has a customer. And that the orders usually don't come from more than one customer, so we're modeling this also as a one-to-N relation. An order has a customer hopefully has lots of orders. And in their generated code that their plugins will create, we get a getCustomer method on the order class that we can call in order to retrieve the customer object. But by default, it's going to load that information lazily. And so what will happen is that maybe we called that a moment ago, and therefore, all right, they already cached that result, we'll get it back immediately. Or maybe we said when we specifically loaded the order, please do an eager load. Go in and also dereference some of these relations and pull in those objects, creating those POJOs as well. But if we don't say to do some sort of an eager load, and if we haven't asked for that customer before, now we turn around and we call getCustomer, and we have to go do a database I/O in order to be able to retrieve the customer, in order to be able to respond with the customer POJO. We've got to have the data. This is beautiful from an OO standpoint, but it comes at a cost. We have to maybe do some database I/O, and that's got some potential downsides. We like having pure abstractions. We like saying that everything is pure objects, it's all methods. We don't care about the details of disks and networks and all that fun stuff. But your abstraction is only as good as the environment allows it to be. You can't necessarily hide all that stuff, and that when it comes to actually getting these things to work right. In the particular case of getCustomer, if you are on a background thread and you call getCustomer, that's fine. But if you take that order object and you handed that over to your UI, maybe you use data binding and that in order to put the order into your layouts, and that let the views get populated from it. Well, now somebody goes in and says, oh, okay, well, I want to show the customer name on the screen, and so we do getCustomer dot, get name or whatever, and now all of a sudden, we're maybe doing disk I/O on the main application thread. Data binding is just going to call getCustomer, and if we don't already have the customer object by one means or another, now we're going to do the disk I/O in the main application thread, and strict mode will complain at you. And if you're not using strict mode, what up with that? And so you'll crash in development or whatever you have set your strict mode penalties for. That's not good. And so ideally, we would have a getCustomer method, but in practice, having one of those is dangerous. And so Room takes the approach of saying, all right, we're not going to offer that sort of a method to force you to think about when and where you're doing your data loading. It's closer to the retrofit approach. When I do the database call equivalent and that for retrieving the order, I don't get the customer necessarily out of the box. I'll get maybe a customer ID, and there are ways that you can, for certain circumstances, say, all right, I also want to go in and get some details about that customer in one shot. But more often, that's not the way it's going to work, that you're going to need to wind up making multiple calls on your DAO in order to be able to retrieve everything and, again, stitch the results together. And the reason for that is the main application thread, trying to avoid making calls on the main application thread, and that force developers to think this stuff through, loading in what they're supposed to load. And so we don't get magic getter objects. I've got a category class that is in a tree structure. Categories can have subcategories and sub-subcategories and so forth. And so I can declare the foreign key. I can say, oh yeah, I've got a foreign key back to me, and that where my parent ID I make is going to map to the ID, and if you delete the parent, please go in and delete all of its children. But I don't wind up with a category, get parent method. I don't have get children or anything like that. All I have is the parent ID, and that would force me to turn right back around to my DAO in order to be able to go in and load in the child categories given a parent ID, where we do the select call. Yes, can you use some fancy SQL in order to maybe you can get one layer automatically loaded for you out of this way? Sure, and that for an arbitrary deep tree structure, eventually you wind up making more DAO calls, and you're going to need to be able to deal with that. M-to-N relations, and that you can say, oh, okay, well, I'm going to have a customer, and that I'm going to have the customers belong to categories. ORMs, your green DAOs and whatnot are going to go in and say, all right, well, we're going to generate, join tables and whatnot for you. Room doesn't work that way. You're going to wind up modeling those join tables yourself. And you're going to wind up with really long entity annotations as a result. And that where you've got your complex primary keys, where it's, the join table, the primary key is the combination of the two child keys, and that I've got foreign key relationships back to my customer and my categories, and you wind up where you then have to turn around and do your inner joins and whatnot in order to be able to say, I want to get all the categories for a particular customer. I want to get all the customers for a particular category, things along those lines. And so all of this is with an eye towards trying to make sure that we don't give you magic where the magic can burn you, and that we don't give you a get customer, we don't give you get categories, and that you somehow wind up invoking those things on the main application thread, which is bad for business. The other thing we need to think about is in terms of what we are really modeling here. We like to think that our model objects are model objects, that they are representing abstract business concepts and so forth. How many of you have seen this diagram before? Pretty popular. And this diagram is from a gentleman named Bob Martin, who, according to published reports, is somebody's uncle. And he's got his clean architecture advocacy, and where he says, okay, as you're thinking about these layers, you really want purity as you're heading kind of inside of his nested circles here. And so your entities, as he refers to them, are true POJOs, that they don't know anything about the web, they don't know anything about the database or anything along those lines, that they implement business rules in conjunction with use cases, and it's only as you are getting wrappers around those that you start dealing with, oh, okay, well, how am I getting this stuff to and from my web service? How am I getting this stuff to and from my relational database? And so those model objects, therefore, or what he refers to as entities, don't have any knowledge about persistence or servers. And that now, depending upon the nature of your app, How much in the way you have of use cases and entities on the mobile client, and that is up for debate. Maybe a lot of your smarts are more on the server, and in which case, you may not have too many scenarios and that you're going to have to model directly on the Android device. Again, it depends a lot on the nature of your app. But we have a tendency with these clean architectures to say that we want those POJOs to be as pure as possible, as little knowledge of where and how they're coming into the world, and that in terms of persistent data stores, and that as possible. So there was somebody who asked a question out on Stack Overflow 3 or 4 weeks ago, and that they were trying to come up with a Java class that not only supported I think he was using retrofit, and that but also the same entity was going to be using room and was trying to figure out how to get all the annotations together. Technically, that's possible, and that those annotations probably don't conflict at all, and that you can probably pull that off. But from a practical standpoint, none of that's necessarily going to make sense. So, how many of you are working on apps where you talk to a web service? Keep your hands raised if the Android client team controls the web service and what responses it returns. Yeah. And that for the rest of you, there's somebody else who's responsible for that. There is some sort of a server team who is going to be deciding what the web service is going to be responding. And that what are the URLs, what's the payload format, what's the data in that payload. And they may not have had the Android client in mind when they were developing it. Maybe they were thinking about the web client or something like that. And so the server, what it returns, may or may not necessarily be a one-to-one map to the way you want to have these objects be in your Java code, and that in terms of those entities and use cases. It may be that, you're going to need to change those around, that you've got one set of objects that you're getting from your retrofit or whatever, and something else that you're using. Because maybe today it all lines up, but then tomorrow the server team goes in and decides, okay, we're going to come up with V2 of our web service API, and they're going to change it all around because they decided to do something to, more optimize for a fruit-flavored operating system or something like that. And so, then now all of a sudden those payloads change. How much of your Android app do you really want to have changed with that stuff? And so, if you're using things like repository patterns and whatnot, there's a very decent chance that you're going to say, oh, okay, well, the way we approach this is that we're going to say that retrofit, what we're modeling with the POJOs that we're using with retrofit isn't our models, it is simply data transfer objects. That they are things that are modeling the server, and what the server wants and how the server structures it, we are then turning around and mapping those into our own structures in order to be able to then have a clean set of objects that are not dependent upon the whims of some server team. Room is a little bit easier in the fact that your server team probably doesn't care what your SQLite database looks like. And if they do, they've got control issues. But instead, you're going to need to deal with the fact that, hey, relational databases and objects have never gotten along well. That's why we have complex phrases like object-relational impedance mismatch that we've been bandying about for a quarter century. It just doesn't really work all that well. Our room entities start off already not looking very pure, and that they've got all of these annotations, and some of these annotations may be bigger than the Java code. And we can't just, there's no rug big enough for us to sweep these things under, and that clearly this object knows something, at the code level at least, about the persistence, even if maybe the actual fields and methods that we're using on here and that aren't perhaps directly dealing with the database. But beyond that, we're not necessarily going to be able to map everything perfectly. We're going to have some limitations on this stuff. Relations, and that they don't necessarily map cleanly. Our data types don't necessarily map cleanly. Room's got support for an embedded annotation to say, okay, I want to take this set of columns, and rather than them going straight into an entity as fields, I want to map them to this other object, and that object goes in as a field. That's a specific case of a more general situation which they handle with type transformers, which says, okay, I want to be able to say, all right, I've got this object, I want to be able to marshal it to and from some data type that SQLite knows, like a string or maybe a byte array or something, and I've got methods that go to and from whatever class I want, dates, and that locations, points, and that customers, whatever, and that I want to turn around and I want to mangle into a single column inside of a database. Those only get you so far. And that there's reasonable chance that what you would want in the absence of any of this persistent stuff, that what you'd want as your object structure isn't going to quite work directly with Room for one reason or another. And so don't be afraid to similarly consider this to be a DTO sort of scenario where we are loading in our objects and that from Room, but then we wind up, just as we do with the server objects, converting them to something else that is more amenable to the way that we want our business logic to work, and not necessarily try to say that, all right, our Room entities have to be the entities and that from the Uncle Bob clean architecture and be able to turn around and then say that the persistence is handled separately. So overall, if you're used to retrofit, Room should be a fairly easy jump, and that it is spiritually in common and it is relatively straightforward in order to be able to say, all right, I want to apply that same sort of techniques, and that whether it's network backed or whether it's SQLite backed. We've got about 4 minutes or so. If anybody's got any questions, step up to the mic.